Good morning, dear students. Welcome back to the next lecture on the soap. I hope the first lecture on the soap was quite interesting for you all. And while washing your hands, you were remembering all the points we have discussed about the soaps, how the cleansing action takes place when we use the soap, the different types of the soap we use, and what are the advantages, disadvantages of the soap, looking the historical background of the soap. Now we understand how the soaps are manufactured at a large scale in the manufacturing of the soaps. What are the prerequisites required for this lecture? You better understand the soaps, the history of the soaps, what was the background of the soaps, manufacturing, the types of the soap, the saponification reaction of making of the soap, the cleansing action, advantages and disadvantages. So in this lecture, we should cover the following points: the manufacturing process, the raw materials used in the manufacturing, the cold process of the manufacturing, the hot process, the batch process, and the continuous process. What will be the learning outcome of this lecture? Students will be able to understand about the manufacturing method of the soaps at a large scale in the industries, how they were manufactured. So before going to the manufacturing method of the soap, we should know the raw material used in the soap making. The soap require two major raw materials for the basic reaction, that is saponification reaction, that is the reaction of making soap, the fat and alkali. The alkali most commonly used today is sodium hydroxide. The potassium hydroxide can also be used. We have discussed that if we use the sodium hydroxide, the soaps which are produced, that are hard soaps, which do not produce lather quickly. And if we use potassium hydroxide, it produces quick lathering. The potassium based soaps creates a more water soluble product than the sodium based soap, and so it is called soft soaps. The soft soap alone or in the combination with the sodium based soap is commonly used in the shaving products, shaving creams. In that alone soft soaps are used, and sometimes with a combination of the sodium based soap, it is also used. Now we talk about the fat which is used in the preparation of the soap. The animal fat in the past was obtained directly from the slaughterhouse. So there the fat is collected and used for the soap making. Modern soap makers use the fat that has been processed into the fatty acids. So the fat should be processed into the fatty acids and then it is treated with the alkali. This eliminates many impurities and it produces as a byproduct water instead of glycerine. If we use direct the fat, we have the byproduct glycerin. But if we process the fat into the fatty acids, we have the byproduct water. Many vegetable fats, including olive oil, palm oil, coconut oil, can be used in the soap making. Besides the main raw material used for the soap, the additives are used to enhance the color, texture, scent of the soap. So if we see the main saponification reaction, it produces a dull soap which is usually a gray or the brown in color. But to enhance the color, when we see it, we just attract to it. For that purpose, we use additives. And the soap fragrance really attract us. Perfumes are added to the soap mixture to cover the odor of the dirt and to leave behind a fresh smelling scent. The abrasives to enhance the texture of the soap are also added, like talc, silica, marble pumice, volcanic ash. Soap made without the dye is a dull gray or brown color. But if we use the dye of the different color we want, we make it so attractive. So the modern manufacturers color soap to make it more attracting to the consumer. So the dyes are used for the coloring, the other additives like to improve the texture. We have the talc, silica, the marble pumice is added, the fragrance is added in the form of the extract or the perfume, as well as various disinfectant are also used as a additive, like neem and eucalyptus extract of the plant. Even the germicide is used for preventing the dandruff. We use the additive. Specifically, the sulfur is added for the cure of the dandruff. And to prevent the skin for becoming rough, we just use a smooth super fatting agent, the fatty material from the sheep's wool. Generally, it is added to have that smoothness of the skin. So, to prevent the pimples, which generally occurs in the adolescent age, so for that purpose also, so various additives are used to enhance the function of the soap besides the main function, that is cleansing. So here you can see the raw materials as we have discussed, the alkali materials, the fat, the alkali which we can use the potassium hydroxide and sodium hydroxide, the fat which can be used, the animal fat. So here the tallow with the 20% grease, the tallow fat, it's the animal fat. The coconut oil, olive oil, palm oil are the vegetable oils that can be used for the soap making. Now we come to the manufacturing process of the soap. So the manufacturing of the soap can be divided into the two types. The one is the cold method or the cold process, and the second one is the hot process. So for the special type of the soap, the cold process is used, it takes more time. The cold process takes more time to produce the soap, and the hot process takes the lesser time for the production. So for the special type of the soap, we prefer cold process. And for the large scale, if we want the toilet soap, laundry soap to prepare, the hot process is mostly preferred for the manufacturing purpose. So let us see the cold process of the manufacturing of the soap. So it requires the following steps. The step one is we prepare the lye solution. The lye solution is the alkaline solution used for making soap made up of the sodium hydroxide or the potassium hydroxide solution. So if you are taking the sodium hydroxide, it prepared the hard soap, and if we take the potassium hydroxide, it prepares the soft soap. So carefully measure out the lye and just pour into the water. Stir until the dissolved and add out the thermometer to see its temperature. You have to monitor until the solution is at 110 degree Fahrenheit. Remember, do not breathe in any fumes and wear your protection equipment because the reaction is exothermic. Measure out the oils and the microwave use until it melted out. Stir and add the thermometer. Monitor again until the solution is at 110 degree Fahrenheit. And you have to ready with your additives. What additives you are required to add in the soap. Now the step 2 involves combine the oil which is melted out, the lye solution and the additives. The essential oil for the fragrance, coloring agent, dyes, all you have to add it up. Once both the mixtures are within 10 degrees of each other or below 110 degree Fahrenheit, you can combine all the additives into it. Place the hand mixer in the oil solution until to remove the air bubbles. Slowly pour the lye solution into the oil and slowly mix it up with the blender to pulse the mixture until you reach the light trace. Should resemble the early stages of pudding. So when we make a cake, when we add all the things together, so we have to continuously stir it to mix it up. So that early stage you can have in the soap preparation also. The mixture will start to thicken. Add any additive to the mixture if you want. Stir the blender. Do not pulse with the motor as they accelerate the trace. Divide your base into the other containers for the color or add color directly to the mixture. Stir until it combined, and then it should be poured into the any kind of shape you want, that mold, square shape, heart shape, any kind of the shape we want, to the desired mold we just pour our mixture. So this step should be quickly done so that the mixture goes on thickening out and the proper mixing should be done. Understood? And the mixture can be hardened more rapidly, so you have to go for this step readily. The last step in the cold process is demold of the soap and let it go for packaging and for the use. After 24 hours, we can remove the soap from the mold. Make sure that the soap is firm before we remove it. Cut the soap to the desired size. Place out the soap on a paper bag and just let it cover for 4 to 8 weeks. With the Castle soap, the time is 6 months. The soap is usable after 2 days. However, the lye is still active in the soap. So until water is fully dissipated from the soap, the lye may still be active. So after the cold process, we should understand the hot process. The hot process of the manufacturing of the soap is divided into two types. The one is the batch process and the second one is the continuous process. Now we understand the batch process, which is a hot process, also called kettle process. What is kettle here? The kettle is a large steel plant having the steam pipes connected to the bottom of this tank, the steel tank. So fats and alkalis are melted in a kettle and the mixture get thickened and produces the soap and glycerin. Okay, so this first step is called boiling. Then the second step is salting out. We add the salt in a kettle. So what happened? The salt separates out the soap and the glycerine. So we have the two layers. At the top layer is the soap and the bottom layer, which is settled, that is glycerine. So the soap and the glycerine are treated with the salt, causing out the salting of the soap. The soap, which is lighter, rises up and glycerine as heavier settle at the bottom. If a small quantity of the fat did not saponify, a strong alkaline solution is added in the kettle, for again the saponification takes place and then again the salt is added. So the third step involves if some fat remain unsaponified, for that we process, again add caustic soda solution and again add the salt for complete saponification. So that step is strong change required. And after whole conversion of the soap takes place, the last step is the pitching. So what we separate out the soap from the kettle. Again we take the soap in a kettle and boiled again with the water. So that's the pitching. So again you have to take whatever you have produced the soap and then add the water and boil it. The mass separates out in the form of neat soap. So neat soap containing the 70% of the soap and 30% of the water. Okay, 70. Neat soap is what? Neat soap is containing the 70% of the soap and 30% of the water, and the settling at the bottom layer we have the negre, which is having. So what we have seen all the steps of the batch process. Here you can have a detailed points. The first was the boiling. The fats and alkalis are melted in a kettle, which is a steel tank you have seen just before, that can stand 3 stories high and hold several thousand pounds of the material. So it's a very large steel tank. The steam coils within the kettle heat the batch and bring it to a boil. After boiling, the mass get thickened and the fat react with the alkali to produce soap and glycerine. The saponification takes place. So the second step is salting. The soap and glycerine must allow to separate out by adding the salt. So the soap rise to the top and glycerine settle at the bottom. Glycerine is extracted from the bottom of the kettle. Then we have the third step, that is the strong change. I have told you to remove the small amount of the fat that have not saponified. A strong caustic solution is added, and this step in the process is called strong change, and boil it again. The fat converts into the soap, and again the salt treatment is done to separate out. And at this time, if we go for producing the soap and take it up for the final pitching step, or the manufacturer may proceed to the next. So third step, if the manufacturer want a small amount of the fat which remain unsaponified, can be again saponified by adding the caustic alkali solution, and do it the step again, wait for a while, complete saponification takes place, and finally we go for the next step. So it depends on the manufacturer. He can move further to the next step without proceeding this strong change. The next step, or the last step, is pitching. We have seen the soap in the kettle boiled again with the added water. Okay, the mass eventually separate out to the two layers. It's a neat soap layer which contain 70% of the soap and 30% of the water, and the lower layer is called nigri, which contain most of the impurities like dirt, salt. Okay, so the neat soap is taken out, and then it is cooled out, and we have the desired shape or the size we want of the soap, and it is ready for the packaging and then for supplying. So this how the kettle process or the batch process takes place, by simple the boiling step, in a then we have the salting, then strong change which can be the optional, and the pitching step. So now we see the continuous process, which is a modern process of the manufacturing of the soap. So it involves various steps. The first is splitting. It is very important. First of all, the fat which we use for the soap preparation, it splits into the fatty acids and the glycerin. The equipment used is for this vertical stainless steel column with a diameter of a barrel called a hydrolyzer. So this is one of the important steps. First of all, the fat converts into the fatty acid and the glycerin in a hydrolyzer. Understood? It is made up of stainless steel, and it may be as tall as 80 feet. Pumps and meters are attached to the column, allow the precise the measurement and control of the process. The molten fat is pumped into one end of the column, while at the other end the water at the high temperature and the pressure is introduced. This splits the fat into two components, that is fatty acid and the glycerin. So it pumped out continuously as more fat and water enter. The fatty acids are then distilled for the purification. So this kind of the first step involved in the continuous process, that is splitting. Then we have the mixing. The purified fatty acids which we get from the hydrolyzer are next mixed with a precise amount of alkali. Understood? The sodium hydroxide and the potassium hydroxide. The other ingredients such as abrasives, fragrance, and we can add any germicide, superfitting agent, are also mixed in. The hot liquid soap may be then whipped to incorporate the air. Finally, we go for the next step, cooling and finishing. The soap may be poured into the molds and allowed to harden into a large slab. It may also be cooled in a special freezer. Understood? It takes time to cool down at a normal temperature, so it can be cooled in a special freezer. The slab is cut into the smaller pieces or of bar size, which are then stamped and wrapped out. The entire continuous process from splitting to finishing can be accomplished in the several hours. Understood? So it goes continuing the producing the soap, and we have the finishing, the wrapping, and with the appropriate size and stamped out. It goes on packaging, and then it is to be supplied. So these are the steps. So what's the difference between the batch and the continuous you found? In the batch process, the normally you are taking the fat and saponification is taking up from the basic reaction, but in continuous process the two-step reaction, it proceed out first. The fat convert into the fatty acid and the glycerine, and it can remove more impurities better in the continuous process. So continuous process has the advantage over the batch process. So one more additional step is there in the continuous process, specifically for the toilet soaps, and it is the additional processing called milling. The milled bar lather up better and has a finer consistency than the non-milled soap. The cooled soap is fed through the several sets of the heavy rollers, which crush and knead it. Perfumes can be best be incorporated at this time because their volatile oils do not evaporate in the cold mixture. After the soap emerges from the mill, it is pressed into a smooth cylinder and extruded. The extruded soap is cut into the bar size, stamped and wrapped. So this kind of the processing is called milling, and it provides a better lathering and a finer consistency of the soap by spreading the soap to the several sets of the heavy rollers to crush and knead it time to time, and the perfumes and the fragrance can be added in this crushing and kneading of the soap so that it can remain in the soap, and the volatile oils cannot evaporate in the cold mixture. So that additional step is required in the continuous process called milling, and this is specifically for the bathing toilet soap to be done. So all the steps you have read in the continuous process, you can see here in the flow sheet diagram of the continuous process. As you see here, the hydrolyzer, understood, that's the first step. The fat to be taken here to convert into the fatty acids. The fatty acids are taken in the flash tank, and here it goes on just heat exchanging and forming to have the high vacuum still to remove the impurities. Then it condense out and add the caustic soda into it. We have the stove blender. So after that it goes on the finishing into the flake and the powder. So here it goes on separating the glycerine. Here at the bottom there are the evaporators, so the glycerine is recovered here from the bottom of this hydrolyzer, and We have after that the soap should be just pass through the high pressure pump to remove the impurities, and it goes on cooling in the freezer, and then it should be cutted in a desired shape. Understood? And we have a specified bar of the soap. So these all are the continuous process. So one additional process is done is that milling for the toilet soaps. So this how the continuous process takes place, and it has the several advantages. It is a controlled process. The continuous process we have seen that is takes place in a controlled manner. Less time is required as the batch process, and the yield of the soap we get, that is higher in the continuous process. So that is the major advantage of the continuous, and that can be said as the modern manufacturing process of the soap. So this is all about the manufacturing method of the soap, and as we have the several advantages of the soap to use it according to the type of the additive required. So this is all about the manufacturing method of the soap. Thank you and take care.